Greetings to all the viewers. The session is going to deal with the concept called caustic embrittlement. Caustic embrittlement is the process taken as a boiler trouble. This is the part of water and its treatment chapter where we are dealing with the kind of series of sessions based on engineering chemistry topics. All are available at the channel Dr. KAVITHA Chemistry Academy, right? In continuation to all your concepts, caustic embrittlement taken into the consideration for the session. Caustic embrittlement is the phenomenon in which materials of boiler becomes brittle due to the accumulation of caustic soda. Whenever caustic soda accumulated within the boiler, that is inducing brittleness, which is said to be caustic embrittlement, right? Here is the kind of representation. You can clearly notice weakness or failure of the boiler body is possible due to the accumulation of that caustic soda within the boiler. Formation of brittle and crystalline cracks in the boiler is called caustic embrittlement. The main reason for this will be alkali metal carbonates. Whenever sodium carbonate in specific and bicarbonates when fed in the water, lime soda process is likely to introduce sodium carbonate as the washing agent, as a cleaning agent. In order to soften the water. Sodium carbonate having tendency to decompose at the higher temperature, being it is unstable at the higher temperature, so that sodium hydroxide and carbon dioxide will be liberated, due to which boiler water has become caustic soda. There is an introduction of sodium hydroxide by means of lime soda process, where sodium carbonate introduced into the water decomposed into sodium hydroxide. There is the origination of sodium hydroxide within the water. As we are boiling water for the steam generation in a boiler, water evaporates continuously, so that sodium hydroxide will not be evaporated and its concentration progressively increases within the boiler. That may cause sodium ferrate within the boiler body, being it is attached or combined with the iron, being boiler is made up of iron or steel, so that sodium hydroxide mixed up with that steel and generating sodium ferrate, Na2FeO2 will be originated. There is a kind of concentration cell within the boiler. Anode is a kind of made with the iron, where the bent side crocks are present. A small tiny holes, pin holes were present. There the part of iron is indicated as anodic region. High concentration NaOH will be accumulated in those small pits, so that sodium ferrate formation taking place. Wherever plane surface of iron is there, there is no probability for the accumulation of sodium hydroxide, and that is indicated as a cathodic region with the plus sign. This is the way a concentration cell will be originated within the boiler because of the sodium hydroxide accumulation at the cracks, bends, or a small tiny holes. This caustic embrittlement boiler parts like bends, joints, rivets, wherever present, there is a kind of boiler failure may take in place because of the formation of such kind of anodic tendency. Iron at the plane surface, sodium hydroxide may not be accumulated and sodium ferrate formation may not be taken place. That's the reason why decay or corrosion may possible where the bends, where the cracks, where the tiny holes are present, there the corrosion is possible. Caustic embrittlement can be prevented by maintaining pH value, being alkaline solutions are generating sodium hydroxide. That is only the reason to induce the caustic embrittlement within the boiler body. That's the reason why pH must be properly maintained. You can simply neutralize whenever alkaline solution is present within the boiler, so the time to time pH check is very essential. Sodium phosphate can be applied instead of that lime soda process. In the lime soda, you're applying lime like sodium carbonate. Instead, you can go for the sodium phosphate as a softening agent. Wherever sodium phosphate added to water, that may not decompose, that may not release the sodium hydroxide within the water of boiler. That's the reason why you can avoid the generation of sodium hydroxide and embrittlement can be completely prevented. Caustic embrittlement can also be prevented by tannins and lignins as well. Sodium sulfate also applied. Caustic soda solution infiltration of caustic soda solution blocking the hair cracks. Whenever a small pinholes or cracks are present, you can apply the tannins over there so that the plane surface will be generated. So sodium hydroxide may not be accumulated inside and anodic generation may not be generated. Corrosion will be completely prevented. Brittleness we can avoid, right? So this is the way we can prevent the caustic embrittlement. The entire concept related with the caustic embrittlement concept is completed. Hopefully you understood the concept, and we gave the detailed explanation regarding this one, and concentration cell is also manifested. Causes, impacts, and the prevention methods all are indicated over there. And it is a question given in the engineering chemistry for the long answer question as well, and most important topic, right? Thank you very much. Signing off, Dr. Kavitha Kottireddy Kota.